last part of our triangle lecture is on similarity. Polygons with the same shape but different sizes are called similar. For polygons to be similar, both their corresponding angles must be equal and the corresponding sides have to have a constant proportion. Notice the rectangles below all have equal angles, but the ratios between the sides is not constant. Similar polygons have a constant ratio between sides. This means if we compare the length to the length or the width to the width, we would get the same ratio. So we can see in rectangle A, I have a length of 80, and in rectangle B, I have a length of 20. 80 over 20 gives me 4. If I also look at the width, I have a width of 40 in A, and I have a width of 10 for B, which also gives me 4. So I have the same proportion when I compare sides. When looking at similar triangles, it's important to identify the corresponding pairs of angles. When I look at triangle ABC and I look at triangle PQR, I notice that A is 41 degrees and P is 41 degrees. So A would be corresponding to P. B is 85 degrees, so is Q, so B will correspond to Q. And then lastly, C is 54 and R is 54, so C will correspond to R. In this set of triangles, I have triangles TEX and WAS. I can tell that T and W go together, they're both 95 degrees. A is 35 degrees. E would be corresponding, so E would also be 35 degrees. When I look at X, it's 50 degrees, which says S is also 50 degrees. Given the two triangles below are similar, let's find the missing sides. Notice that we know the base of each. We know A, the base is 16, and in B, the base is 6. So we know this comparison that 16 compares to 6. To find X, I will also compare the heights. So I have a height of 24 and I have a height of X. It's important that you pay attention to how you set up your proportions. So because I used 16 from the first triangle in the numerator, I want to use 24 from the first triangle in the numerator as well, and then I'll put the links from B in the denominator for both of my fractions. Now I'm going to cross multiply 16 times X, and that'll be 24 times 6. So I'm going to grab my calculator. 24 times 6 gives me 144. We'll divide by 16. X is equal to 9. Now I want to do the same thing to solve for y. I'm again going to use the 16 and 6. And this time I'm going to compare it to y over 12. Again, the 16 and the y on the top, they both come from my first triangle. The 6 and the 12, they both come from my second triangle. Cross multiplying, I have 16 times 12 is equal to 6 times y. 16 times 12 gives me 192. This is 6y. I divide by 6, and that says y is 32. We have two more triangles that are similar. I have 18, 7.5 in y for my triangle A. I have x, 5, and 13 for triangle B. I'm just trying to find the two missing sides, so I want to find x, I want to find y. Notice again I have the bases, so I have 7.5 over 5, and that's going to compare to 18 over x. Cross multiplying, that's always what we're trying to do when we're solving similarity. So I have 7.5 times x, and then I have 18 times 5. This says 7.5 times x is equal to 90. I just want to divide by 7.5 to get x. So I have here x is equal to 12. Now let's solve for y. Again, I'm going to use my 7.5 over 5, and that's going to be y over 13. I'm going to do 7.5 times 13 is 5y. So 7.5 times 13 gives me 97.5. Let's divide by 5. Y is 19.5. In this one, it appears that I only have one triangle. I have this big triangle that has 10, 8, 6, but then there's an X inside. So what I want you to see is this as two triangles. I have a big triangle with a height of 10. The 8 and 6 together becomes 14. And then I have a small triangle that I'm pulling from inside. Here the base is 6 and the height is X. So I like to really separate if they're put together so I can clearly see all of the components, and really important that I add the two bottom pieces, the 8 and 6, for the bigger triangle. All right, so I only have one thing to solve for. I'm only asking for X here. So I can compare 10 to X the same way I could compare 14 to 6. By now you should know we're going to cross multiply. So 10 times 6 is 60. I have 14 times X, and then we're just going to divide. This gives me 4.2, let's call it 9, if I decide to make it into a decimal. If you just decide to leave it as a fraction, you could make it 30/7. Watch the homework, see what it asks you to do. On the test, I'll tell you what I want. Let's look at an application. A 6-foot tall person standing 18 feet away from a building has a 9-foot shadow that ends with the shadow of the building. How tall is the building? So what I want you to see is this as similar triangles. So what do I have? I have this 6-foot tall person who has a 9-foot shadow. So that gives me a triangle of 6 and 9. What I also have is a bigger triangle. So the 18 and the 9 comes out to be 27. And I don't know X. So this looks a lot like the last problem we did. The last problem just didn't have an application. So once again, we're going to set up our proportion. So I'll look at X compares to 6, the same way that 27 compares to 9. We'll cross multiply. Here's 9X is 27 times 6. This is 9X is 162. So divide by 9, divide by 9. This says the tree is 18 feet tall. Let's try that again. This time we have a 5'6" woman who has a shadow of 1.73 feet long. At the same time, the shadow of the Eiffel Tower is 334.85 feet. And what we want to know is how tall is the Eiffel Tower, and I want you to give that as a whole number. So this is just like that last problem we had about the person that was 6 foot tall and their shadow and comparing it to a tree. Except now I have a 5'6" with 1.73 feet, and I'm looking for the height of the Eiffel Tower. We'll call that X, and we know the shadow was 334.85. The first thing we have to deal with is the height of the woman. So it says 5'6". Well, think back, we've done conversions, that there are 12 inches in 1 foot. So 6/12 is 0.5. So this woman's height is 5.5 feet. So that's the first thing we need to do, is just take care of having everything in the same unit. Now I can compare height to height. So I can say, well, the 5'5" woman compares to the height X the same way that 1.73 compares to the shadow of 334.85. We're very used to what to do now. We are going to multiply across, so I have 5.5 times 334.85 is equal to 1.73x. 5.5 times 334.85 is 1,841.675, and that's 1.73x. I'm going to divide by 1.73. And I have X. Remember, I said just make it a whole number. So I have 1,064. It says 0.55. So let's make that 1,065 feet high. Last problem. We're going to find the value of X. And we just have to pay attention to kind of the orientation of this one, where it kind of looks like it took a little twist. It looks kind of like a bow tie. So what we can tell is I have this 20 inches that works like a base compared to this 16. This 12 is going to compare to the x. So I want to say 20 compares to 16 the same way x compares to 12. I'm going to go across. 20 times 12 is 16x. That says 240 is 16x. Divide by 16. That gives me that x is 15. It's in inches. Notice I just kind of carry the units along. Don't worry about them too much until the very end because the units were all the same.